So they given the parameters of RPM, compression ratio, continuous L, and and combustion which ends at 20 degree after TDC. So you need to go for the displacement volume, which is nothing but pi by 4 d square L. D is nothing but the bore, and L is nothing but the stroke length. Yes. Here they given bore and stroke are same. So either you can take it as S cube or B cube. Okay, since both are same. So when you calculate the B value, you're going to get this in terms of meter. And when you're converting to that in centimeter, you will get 8.60. You have either one in either you have it in meter or centimeter. It's good to have in meter as we follow all the other units in meter, so you better have it in meter. Okay, and you also have the formula to calculate the average piston speed, which is nothing but 2 into Sn, where S stands for the stroke length, and N stands for the speed. So here the speed is 3600 RPM. It is revolution per minute. When you want to convert to per second, so 1 minute is having 60 seconds. So revolution per minute. So when you want to convert that to second, so divide by 60. Per minute per second. So if you want to have per second, then it is divided by 60. Okay. So you need to convert that accordingly. So 3600 by 60 revolution per second, and this is the unit that you have for stroke length. It is meter per stroke. Okay, that meter you have for one stroke. So this is the average piston speed. You know, the piston speed is nothing but the velocity. The unit of velocity is always meter per second. Okay, and you need to calculate the third one, which is nothing but the clearance volume of one cylinder. You know, the clearance volume is nothing but VC. VC is the clearance volume, and you know the compression ratio is nothing but overall cylinder volume divided by the clearance volume. The overall clearance volume is nothing but VD plus VC by VC. So here VC we need to calculate. You know the VD which we calculated here. Maybe you can also do check using your calculator. And then what you have to do is you should also find out the VC, which is nothing but the clearance volume, and it can be either in meter cube or in centimeter cube. Okay, so when you do the reverse calculation, you can able to find VC. Maybe you can also check it now, your calculator, whether you're getting the value or not. And there is a formula for crank offset, which is nothing but S by 2, where S stands for the stroke length and A is nothing but crank offset. We have seen this during the theory class also, where R is equal to small r by A, which is R by L we have seen. And we know the crank offset is 4.3 here, and canting rod length is 16.6, where we also seen this. We have seen the formula in the case of theory class we have seen. I have used that here. So you get 3.86. And here what you have to do is you have to calculate even you also need to calculate the heat balance sheet. So after you will get the answer for first 4. The remaining 2 I have not asked because it is something you have a lot of derivations with respect to you will have a lot of modeling equations to find out the distance the piston has traveled from TDC, because you need to use the theta value in terms of 20 degree where the cos theta values will come. So it will be slightly difficult. So you need to concentrate on these things. So the very basic things you can make more about. If you have any doubts, you can ask me. I will also see if you're not getting answers. So now we will see the heat balance sheet on example in the next question. So if you have any doubt in this, you can ask I will just give 1 or 2 minutes. Then we will go with the next one. We have seen these questions and answers in the first class also, but you can also revise it once again. Regular problems, okay, you just practice it. Okay, so this is very much important. Respect to the heat balance sheet. So this is the heat balance sheet. Normally you have the template. So what in the heat balance sheet, what you have to find out? What is the heat carried away from the break power? What is the heat carried away by the cooling water taken? What is the heat carried away by the exhaust gas? What are all the heat unaccounted loss? So you need to find out these four parameters uh, during your calculation. You need to calculate how you need to calculate is that the heat balance sheet for an IC engine. So this is a general template that you have. First is brake power. So this is an example. Here what they given the bore value, stroke value. They given the speed value. They also given the effective brake drum diameter. They given, and they also given the brake load, indicator mean effective pressure, fuel consumption. They given calorific value of the fuel. They given, and then they also given the mass flow rate of the fuel, the temperature rise of the water jacket cooling, and they also given the temperature and what is the mass of the air and the temperature of the air, and temperature of the exhaust gas, and the mean specific heat of exhaust gas. So given all these parameters, now they ask you to calculate the heat balance sheet. And before you go to the heat balance sheet, you need to calculate the brake power, indicator power, mechanical efficiency, brake mean effective pressure. So if you are calculating all this, then it will be easy for you to write down the heat balance sheet. And it is like just a profit and loss, what you put it in the finance in the case of in a company. So if you are working in a company, I will tell in the company language. So you normally have a balance sheet at the end of the year where you put profit on one side and loss on another side. Similarly here, you need to match the 100% of the heat supplied by the combustion fuel into the different percentage which is being shared by different in the form of different heat. Heat can be lost in the form of brake power, or it can be lost by the exhaust gas or any unaccounted loss. So you need to divide it accordingly. So here the formula here is brake power. Brake power is nothing but 2 pi n T by 60,000. So torque is nothing but Newton meter. That is the force into displacement. So here even the force is nothing but 440. Okay. Displacement is always either meter or centimeter. So here the displacement is W minus S, where 25 minus 20. So sorry, not 25 minus 20. Here it is they given the brake drum diameter. Okay. So the brake drum diameter here is 1.2. Okay. So which is nothing but W is nothing but the, the, the diameter in which the drum gets operated, okay, into the radius. What is the radius of the drum? Okay, which means R is equal to D by 2. So when diameter is nothing but 2 into R. So diameter is nothing but 2 into R, where you get uh, 2 value and 0.6. And see here they given the drum diameter as 1.2 meter, which means the radius will be accordingly r is equal to diameter by 2, and you have to get to 0.6. Okay, and again you have to put the radius, which is almost same, into 2 you have to put here, and 2 pi value is 3.14. So 2 you have to put here, pi value 3.14, and you have to put RPM 2 pi n is nothing but the speed, which is nothing but 6 RPS. Okay, because they given we have to convert value into second here, so they also given in second. So 2 pi n into the torque is nothing but 440, is nothing but the force into uh, the displacement or the diameter. So effective brake diameter. Okay, so here it is 1.2, so you need to divide that by 2 to get the displacement. Force into perpendicular distance will be the torque. So when you do the calculation, you get 9948 kilowatt. Okay, and the next important thing is the indicator power, which is the formula is Planck by 60,000, where PM is the effective pressure, A stands for area, L is the length, and N is nothing but the speed. So they given the value mean effective pressure as 280 kilopascal. Indicator mean effective pressure 280 kilopascal. So you need to convert that to Pascal. So to 10 to the power 3. Here is nothing but the area, it is nothing but pi by 4 d square. So, you know, pi by 4, where d square. So here diameter d is nothing but diameter, so 20. So you need to convert that into a meter. So that's why you're going to divide it by 100. Pi by 4 d square, you need to square it. Into L stands for length. Again 25 divided by 100, because you need to convert that into a meter. Into N stands for the speed, which is nothing but 6 RPS. So you get, when you do the calculation, you get this much this the value. Maybe I will give some few seconds. You can also take it using your calculator. Yes, if you're not getting answer, please let me know. You can ask, you can expect a similar questions, but data may be different. Yeah. So when you practice this, then it will be easy for you to answer whatever has been asked the questions. Let me know if I'm going very fastly. What W is load, right? 1 second. W. You're asking, okay, this W. Okay. Okay. So here I will tell you in another way. It is confusing to you. Brake power, you know, general formula 2 pi n t by 1000. Okay, by 60,000. That is the general formula you have. So here torque. What is nothing but torque? Torque is nothing but load into perpendicular distance. Okay. This for load, what is the load? Load is nothing but it is in the form of Newton. Force. Force is nothing but load. So here 440 is nothing but the load actually. Okay. And the perpendicular distance is the effective diameter divided by 2. So the effective diameter is 2.2 divided by 2 will give you the perpendicular distance basically. But in case sometimes what happens, you will also get the different thing like W minus S, which is nothing but the effective brake load, and then the effective brake stroke. That is a big complicated one. You don't need to worry about W minus S. So here you can keep it the formula 2 pi n t by 60,000, where n stands for the speed, 2 pi is standard one, and load into perpendicular distance is the torque. Load is nothing but 440, and so perpendicular distance. Okay, the perpendicular distance is nothing but the effective brake drum diameter, because the brake is nothing. What is nothing but brake? Brake power is nothing but the power which you are measuring at the output of the crankshaft. Okay, the crankshaft is having the diameter. Okay, it is nothing but the diameter in which you are connecting the brake into the brake load into it. Okay, so you need to divide the brake drum. It is basically a round shaped one. So what is the perpendicular distance of the round diameter? It is nothing but half of the diameter will be the round. So here you don't need to worry about W or S. You need to worry here is the torque 2 pi nt. Torque is nothing but load into perpendicular distance. So load here is 440. Okay, perpendicular distance is half of the effective drum diameter. So you need to worry. Okay. Yeah. So next important thing is mechanical efficiency, which is defined as a ratio between brake power and by radiator power. This we have seen it in the theory class. Brake power is, you got this value in kilowatt, and even the indicator power also in kilowatt. Then you get the mechanical efficiency. Okay, the direct formula. So you have to multiply it by 100. So you get 75.41. The brake mean effective pressure is, if you are asking to calculate the brake mean effective pressure, which is nothing but indicator mean effective pressure and mechanical efficiency. So you know indicator mean effective pressure is 280, and you get this value. Indicator mean effective pressure is already there, indicated as 280 kilopascal. Okay, 280 into 0.7541, you get 211.15 kilopascal. So same unit you have to put. So the unit of indicator power mean effective pressure kilopascal. So same kilopascal you have to put it here. Okay. So the next important thing is fuel consumption. You know the unit of fuel consumption is kilogram per kilowatt hour, and so kilogram is nothing but the mass flow rate of the fuel. They given in the problem they given the mass flow rate of the fuel as 3.6, and kilowatt hour per rate. Okay, wait, this is the brake power. Okay, so with respect to the brake power, you need to calculate what is the fuel consumption, because uh, they are asking to calculate the fuel consumption in kilogram per kilowatt hour on brake power basis. Okay, so if they're asking to calculate the fuel consumption based on brake power, so what you have to put is you have to take the brake power value whatever you got. If it is based on the indicated power, that then it should be technical 188. But normally it's always towards the brake power. Okay. So that's why you have to take you need to give 3.6 divided by 9.948. So in the problem they given a 3.6 value. That is nothing but the fuel consumption. They given 3.6 kilogram per hour. Hope you got this value. And then now we are going for the important step called the heat balance sheet. Okay. So always remember that in heat balance sheet you have four important parameters you need to calculate. you need to calculate what is the heat, which is heat loss. Basically, heat equal is nothing but heat loss. How much is heat loss to the brake power? What is the heat loss to the water jacket? What is the heat loss to the exhaust gas? And again, what is the heat loss to the unaccounted loss? So all these four losses you have to find out. Okay, so all these four losses you have to find out. First, what we will do is we'll see what is the heat supplied by combustion of fuel per minute. It is nothing but the heat supplied by combustion of fuel per minute is nothing but the mass flow rate of fuel, which is given as 3.6 into the calorific value of the fuel. They given the calorific value as 42,500. So this is the calorific value of the fuel. Okay. Please let me know if in case if you feel very difficulty something. You can also look into the same questions while you're practicing it. And again, heat equivalent of brake power per minute is nothing but the brake power into 60, because per minute. Okay. So when you're converting that, because you would have got in hour, brake power kilowatt by hour you would have got. So 1 minute is nothing but 1 by 60 of hour. So 1 by 60 will be the 60. Okay. You need to multiply 9.9 60, you get this is nothing but the heat equal to that of the brake power. This is nothing but the heat equal to that of brake power, or nothing but the heat loss to the brake power. And next, what you have to find out is, let me see if any questions are there. That was the best of. Okay, as of now, no question. Okay. Please let me know whether my screen size is visible or not, because I hope it is visible. Yes, alignment getting changed actually. Okay. In case if it is getting blurred, please let me know so that I will. Okay. So next, what you have to find out? You have to find out the heat loss to the water jacket. Again, this is the general formula, which is nothing but mass flow rate of the fuel to the specific heat of the water into the rise in temperature of the water cooling jacket. So here the mass flow rate of water they given as 468 in the problem, and you need to divide it by 60. How you have divided here? The same you have to do it here also. Into they also given the specific heat of water in the value is 4.187, and the rise in temperature is nothing but the difference between the two temperature, which you will get as 28. So all these data are given here in the problems itself. They given the mass flow rate of the water as 468 kg. Okay, somebody is calling. Okay, it is not from WLP. Okay. If in case anything, you just make a call immediately. If in case any issue feel um, okay. Okay, so here they given the rise in temperature of water jacket, which means the temperature the difference. They given directly they given 28 degree. Suppose if they given the inlet temperature and outlet temperature, then you have to subtract that. Then you have to put the value here. But here they given the directly they given as 28 degree. So you have to put that 28 degree the difference directly here. And the specific heat of water is 4.187. That is nothing but the constant value. This also will be given in the exam. The value will be given directly. The only thing is that you need to put and you have to use this formula and you have to find out what is the heat loss to the jacket. So you get 914. Okay. Suppose see, I will give you one more clue. You can able to find out this. You can able to find out this, or if you can able to find out of four, if you can able to subtract that. Just give me a minute. I'm getting a call from wheel box. Just a minute. So please ensure that you are going to upload it will on time next time at least this is an extra burden for me again. So please ensure that next time you complete your exam 10 minutes well in ahead so that you will not face this difficulty next time. So I also understood because of 8 questions you would have also felt more time. That may be one of the reason. Okay. So you have to find out this value here and suppose if you're not able to find out of 4, if you're not able to find out the value of 1, what you can do is you already know the heat supplied by the combustion of fuel, which is coming as 2550 kilojoules. Okay, so you can subtract the three values from the overall value, okay, and then you can find out the one which you do not know. This is a simple clue actually. Well, let us see what is the heat loss to the exhaust gas. So the heat loss to the exhaust gas is nothing but same the mass flow rate of the gas into the specific heat of gas. So in previously we have seen the specific heat of water. So here it is nothing but the specific heat of exhaust gas. And then into the temperature difference. So last time they given the temperature as 28 degree. So here we have to find out the temperature difference. And here you see the temperature difference is nothing but the room temperature and then the exhaust gas temperature. This exhaust gas temperature they given a value as 400 degree, and you need to subtract that 400 degree with the room temperature of either you can assume as 25 degree or 30 degree, but you have to put the assumption here. You have to put the assumption. If it is 30 degree, you have to put as 30 degree. If it is 25 degree, you can put as 25 degree. Sometimes this 30 degree will also be given in the problem. If not given, you can assume as per your even you can consider as 35 degree also as well. But you need to ensure that you are going to write the assumption as well. Okay. So exhaust gas minus room temperature. So here the specific heat of exhaust gas is being calculated as value based on the data which will be given for you. Okay. So you don't need to complicate this one. Okay. I will directly give you this value. Means sometimes I will give you the value directly. I will also give you this. So you only need to do the manipulation. Like you need to do the calculation considering the value whatever given. For that you need to remember the formula. Okay. So here I will tell you what is the mass flow rate of gas. Okay. So this value will be given directly, but I will tell you what is the mass flow rate of gas. So here it is the mass flow rate of gas is nothing but the amount in terms of kilogram, okay, which is indicated as the mass of the fuel per minute, which will produce so and so kilogram of the exhaust gas per minute. So you know this 3.6 per by 60 per kg of fuel per minute will produce 3.60 into 35. What is this 35? 35 is nothing but uh, the exhaust gas. It's not 35, it should be 34. Okay, that is a typo error. And you know, this is the given specific heat of the exhaust gas is 1 kg per kilogram Kelvin. You can use this value 1. And this 34 is, you need to use this 34 value to find out the mass flow rate of the gas, and also they also given the temperature difference. So the room temperature is 30 degree, and if they are not given, you can assume it. And they also given the exhaust gas is 400 degrees Celsius. Considering all this, 34 kg they given. Okay. So what you have to consider is you have to calculate the mass flow rate of the gas. So, but I will ensure that I'm going to give this value to you during the exam, so that you can directly get this answer. You can directly you have to directly use this, and you have to find out this answer. And the last important thing is the heat loss to the radiation, which is nothing but this minus the remaining 3. Okay. Even you have the formula for calculating this radiation separately, but it's quite a difficult one. So if you find out this 3, then it will be easy for you to calculate the last one.